Hello my dear champions, how are you all? Welcome back to the channel. So today's agenda is very simple. Taking one more concept, one more topic out of the chapter, application of derivative. That's what we are doing right now in our Sankalp. Okay, and if you check over here, the topic will be increasing and decreasing functions. Okay, now of course it is very important if you talk with respect to the KCET, one of the simplest and very important topic of AOD. So if you actually see the AOD chapter, right, there are 4 or 5 topics in that. Basically increasing, decreasing functions, rate of change, then we come to maxima and minima, and almost 4 to 5 questions sometimes has been asked in the KCET PYQs. You can go ahead and check the trend of the PYQs. I've done a video for that, so go ahead and check that particular video of the syllabus and you'll get to know the trend of questions coming from this chapter. It means almost it's a sure that one question will come from this topic from this chapter. Okay, means increasing, decreasing function will give you 1 mark for sure, and the best part is it's going to be very simple. How can I say that, sir? Because what this chapter involves is basically doing a derivative and basic understanding of how it works, how it is positive and negative, and you get 1 mark. And of course it will not be very difficult derivative as you have seen in case of the chapter of C and D itself. Here it will be little simpler than what we have done because it is applications of derivative, not the derivative exactly. Okay, so we'll not have that difficulty level of the problems, rather we'll have application based questions from this chapter in the increasing, decreasing function. So very much solvable, and of course this comes as a trick for understanding, you know, 1 onto function also. We have taught you that as well. So that's why this topic becomes very important. I hope this is very much clear to you. Now let's talk about what is the session today about. So as I said, we'll talk about when can we call the function to be increasing in nature. Okay, increasing in nature, and in that also we have something called as a strictly increasing function. We also have something called as strictly increasing function. So we'll have these things. Same goes with your second thing, which is going to be decreasing functions. Decreasing functions, and of course we also have this sub part which has strictly decreasing function. Strictly decreasing function. Got it? In that we'll also see the difference between these two. Means when can we call a function to be increasing or strictly increasing. Same goes with the case of decreasing or strictly decreasing. And then we'll talk about this function applied in an interval. Means basically increasing and decreasing in an interval. So we'll talk about this as well. Okay, this is very important. That's where the questions are asked from. When you see the problems that I've taken today, when you go through that problem, solve them, you'll understand that this is going to be very important. I'll give you a rule also how to get to this. Simple steps I'll give you. If you follow those steps, you're going to solve any question coming your way. So increasing and decreasing in an interval, that also will deal with it. And of course the last one, question solving. So we have taken almost how many questions? We have taken total 11 questions today. Yes, total of 11 questions today. We're going to solve in the class. Will be solved in the class. Okay, so this is going to be very interesting, very easy session, and if you follow this completely till the end, of course you'll be mastered with the topic increasing and decreasing function. And of course you have to go back and solve more questions from your NCERT, from your question bank, and if you have any doubt you can come back and ask me. So can I start the session now? I hope you understand what is going to be the session outline today. Starting with increasing and decreasing function. Basically, when can we call a given function increasing, and can we give some example of the function which can be called increasing? Okay, so let's start from the first question, which is when can we call a function as increasing function? Okay, so whenever you increase, if I have to read this thing, I'll just of course give it to you. I'll read the statement for you, but in the simplest word possible, in the simplest statement possible, whenever if you increase the value of x, if you increase the value of x, keep increasing, what happens to y? What is y called as? Y is nothing but f of x. One second. Y is nothing but f of x. So the functions increase goes like this. F of x basically also increases. So if you increase the value of x, basically you move towards right in the graph of the function. The y function, the value of the graph goes up. See here, if you look at this particular figure, what happens if you move from left to right across x-axis? What happens to the function? It goes up. It goes up. The trend is like this. It goes up. Sir, over here it is not going up. Yeah, we'll talk about that. That is the difference between strictly increasing and increasing function. But understand right now, if I increase the value of x, if x is moving towards right, if you go right in the x-axis, on the y-axis you are going actually upwards. If you see the graph in this fashion, then what happens is the given function is of the increasing nature. As simple as that. So what if the graph is not given to us? What is the graph not given to us? Then how can you predict this? Then we have a trend. That is where we use our derivative approach. That is what we use. So if you don't have the graph, then we use our derivative approach. Derivative approach is there. To understand for all the functions which you can't define the graph all the time. Can you draw the graph for all the functions given to you in the questions? Of course not, sir. Then we have a derivative approach which we call as method number 2. Method number 1 is of course in the graph. See the graph. If it is increasing in nature, then it is increasing. If x moves towards right, y goes upward, always it means increasing function. But in some cases you can't draw the graph actually, then you have to use the derivative approach. That's why the chapter is called as application of derivatives. Now, of course, by looking at this slide, you can understand what happens in the case of decreasing function. The graph goes down, sir. The graph goes down. This is little incorrect because I have taken here the increasing trend also. I'll change that. So this is the case of decreasing function. Means if you move towards right, the y value goes down. Please check. Next is what? Before moving to decreasing function, I had here strictly increasing function. I'll come back to later, don't worry. I want to show you decreasing first. Yeah, decreasing function. Check this out. If you move towards right, if across x-axis you are moving towards right, okay, upon y-axis what happens? On the y-axis the graph goes down. The graph is going down. Means in the increase of x value, what happens? Your y value is decreasing. Basically check here, if x2 is more than x1, okay, f of x2 will be actually less than f of x1. When this happens, you call the given function to be decreasing in nature. Let me show you with the help of the graph. Okay, I'll point it over here. Please check. If I take these 2 points, point here and point here, okay, this value, let's call this to be as x1, this called to be x2. Very clear from the graph that x2 is more than x1, right? x2 is more than x1. You can see this, x2 is on this side, is more than x1 of course, but if you check, this is going to be the value of f of x2 and this is going to be the value of f of x1, right? One second. That's my value of f of x1. F of x1. That's the value of this point, okay? Now if you check this carefully, tell me which is more. Is f of x1 more or f of x2 more? Of course, f of x1 is more than f of x2, even though the value of x2 is more than x1. So x2 is more than x1, but f of x2 is less than f of x1. It means the function is of decreasing kind. Now if you go back to understand the trend in the case of increasing function, it will be just opposite. Have a look. I can draw it over here. So let's call this to be function, this point to be x1 point, okay? This point to be x1 point and this point over here to be x2 point. Clearly it's evident that x2 is more than x1, and of course if you see the graph, this point is called as f of x2 and this point will be called as f of x1. Then what happens? F of x2 is of course higher than f of x1, so more than f of x1. This might be too many markings over here. I'm going to remove that just to make this clear understanding, but I hope this is very much clear how the graph nature is reflected in the cases of increasing or decreasing function. Okay, I'm going to erase this to avoid the confusion. If you understood, it's okay. If not, I have given understanding with the help of the graph already. Okay, please check. So this is just to understand with the help of graph also. Alright, let's move on to the case of a strictly increasing function. What happens when the word is added as a strictly increasing function? So did you notice this this thing when the increasing function was drawn? There was a flat line and then again it went up. There's a flat line over here and again it went up. So this flat line represents that at some interval, in the sum interval, what happens is the values of x1 and x2, even though x1 value, if I take two values over here, let's say x1 and x2. So even though x1 is less than x2, but f of x1 will become f of x2 equals, okay, means even though the values of two x's are different, they are one is more than the other, but the function value at both the point remains same. Is it decreasing? Not decreasing. Is it decreasing? Of course not. But are they increasing also? No. So we will not call this to be decreasing function because it's not decreasing in nature, but we'll not call it to be strictly increasing. When I talk about strictly increasing, the graph goes like this. This is the meaning of strictly increasing graph. Means at every point you take, what happens? The graph, if you take this value as x1, x2, x3, x4, x5, x6, any value you take, f of that value will be of course more than the other one. If I take x6 and x5, if I take x5, x4, any value you take, you'll have, if x5 is more than x4, then f of x5 will be more than f of x4, as simple as that. This is called as strictly increasing function. Okay, have a look. So in this case you had equal to sign, actually sorry, there is a equal to sign over here. There is a greater than or equal to. Please check, greater than or equal to. In this case you don't have any equal to. There is no equal to sign in the cases of a strictly increasing or strictly decreasing graph. There is no flat curve. There is no flat part in the case of strictly increasing or strictly decreasing curve. Okay, that's the only difference. This inequality will become free from the, please check, this sign is not there in the case of strictly increasing, only this will be there. This sign comes in the case of increasing functions. Okay, increasing functions. Clear? Okay, that's the difference between strictly increasing and simply increasing function. So whenever you have this function, you can, what are you going to call? You can call this function to be increasing in nature. You can call this function to be increasing or non-decreasing function. Non-decreasing function means this is not decreasing. There is a flat line of course over here which causes that they are equal at this interval, means all the value of f is actually equal in the interval from here to here. Okay, so it's called as non-decreasing or increasing, or basically also called as monotonically increasing function. Okay, the monotonicity will come to picture over here. So monotonically increasing function will be the case for the first one. This is simply strictly increasing function. Okay, so this is very much clear. The difference is only inequality and nothing else. Okay, moving on to decreasing, this is already covered to you, but before I move on to strictly decreasing function, I want to teach you one example. Let's see how it works. So the function fx equals to 7x minus 3 is increasing on the interval all real numbers. Interval of all real numbers. We have to show that it is increasing in nature. What are you going to do? So you can do one thing is simply draw the graph. Draw the graph. 7x minus 3. Take x value as 0. You're going to get y value as minus 3. Okay. 0 comma minus 3. Take this y value as 0. You're going to get x as 3 by 7. Right. 3 by 7. Basically, if you draw the line, it will come like this. If you can get the graph, check this out. When x increases, y also increases. It means it is increasing in nature for all real numbers. Otherwise, what you can do? Use the derivative approach. Simply find the derivative. You're going to get this as 7, right? This was, it will be 7x as 7 and minus 3 is 0. 7 is a positive number. Yeah. Whenever you get derivative as positive, it means the given function will be increasing in nature. Fx is increasing in nature. Fx is increasing in nature. So you have both the methods over here. Draw the graph, understand from the graph. Otherwise, use the derivative approach to get the answer. I hope this is very much clear. Okay, let's move on to the next one, which is strictly decreasing. Strictly decreasing function. Decreasing already done. Okay. Now in this case again same thing. If you have, check this out. There's an equality over here. There's an equality. Okay. No, there's no equality. Sorry, I forgot. There's no equality over here. My bad. In the previous case also there was no equality over there. Okay, I'll just change that. I missed it. My bad, guys. There's no equality over here. Okay, why would there be equality? Of course x is increasing, right? I'll tell you one thing. Yeah, of course x value will be different, right? X value will be different. This has to be like this only. x2 has to be more than x1. I'm not saying that x2 is equal to x1. This is not required, right? This is not required. Only x2 has to be more than x1. Then only you can figure out 2 points, right? x2 is here, x1 is here. Okay, x2 is and x1 are different, 2 different points. So whenever you have that, if x2 is more than x1, okay, and the function of the 2 points are reversed, okay, means x2 is more than x1, but f of x2 is actually less than f of x1. Means basically, if I keep moving towards right, my function value keeps dropping down. Means across x-axis, if I go right, okay, my y-axis, what will happen? Comes down. It has to go on downwards. It comes down. Please check. Move from here to here. The y value is coming down and down. Okay. So this is called as strictly decreasing function. There is no drop like a flat line in this case. Please check. In the case of a decreasing function, you had a flat line over here. Means if you check this point, x1 and x2, what happened here? F of x2 is equal to f of x1, even though x2 is more than x1. Means for those two, x2, x1, x2 is more than x1, but f of x2 and f of x1 are equal. So this becomes a case of decreasing function or non-increasing function. This case is called as decreasing or non-increasing. Got it? You call this or this. Decreasing or non-increasing case is this, or this will be simply strictly decreasing function. So this was all the conceptual part of this chapter. Now we'll move on to problem solving. So first thing is called as first derivative test of for increasing or decreasing function, what I already taught you in the example that I've taken. Okay, let f be continuous function on the interval a comma b, closed intervals. Have a look. And differentiable of course in the open interval a comma b. This is a must. How come, sir? If the given function is not differentiable to you, then how can you find the derivative of that? Okay, so of course it has to be given continuous in the closed interval, and open interval it has to be differentiable. When that is given, then you can call a function to be increasing if derivative is positive. What is the meaning of this? What's the meaning of this? It means f dash of x is positive, right? And you're going to call the function to be decreasing in nature when just opposite is there, which is called as derivative will be negative or less than 0. Whenever that happens, you're going to call the function to be increasing or decreasing in nature. Okay, if f is a constant function and if you differentiate, of course what will happen? It will become 0. Okay, it will be constant function, right? Derivative of a constant function is always 0. Okay, now points to remember, few things to remember before moving on to the question side. Fx is strictly increasing in AB if derivative of x is equal to 0. Please check, greater than 0, sorry. Check this out. This is not greater than equal to. It is simply greater than. Then what happens is you'll have strictly increasing word mentioned over there. Means graph will never have the flat line. Okay. Strictly decreasing again, less than 0, not less than equal to, only less than 0 will be there for the derivative. A function will be increasing and decreasing in R if, so in the every subinterval of R you have both the cases. Okay, means you have, let's say for example, you go the function like this is there, okay, you come down, you go flat, then again you go back. This is called a both increasing and decreasing kind, right? Alright, a function will be increasing or decreasing in R, of course, so the subinterval has to be following that particular case. Whether it is increasing, then it has to be positive, decreasing, then it has to be negative. See, this part has positive, means this is increasing over here, and over here this is decreasing. So in the subintervals of the whole real number, the function is either increasing or decreasing at different points. I hope this is very much clear to all of you. Okay. Alright, 1 second guys, let's begin. So note, if f is differentiable in the open interval AB and is continuous at the point A and B, then derivative is greater than 0 also. This is very important. I've taken a question on this. What's the meaning of this? It means that if you take an interval over here, let me draw this function to you. Okay, this is the function given to you. What they're saying is at this point, at the boundaries, you define a function like this, right? The domain is like this, let's say a comma b, and in the domain AB, at point A and B, the function is discontinuous. It is not continuous at x equals to A and x equals to B. Then that point A and B will become out of the conversation actually for your domain. Okay, and in that case, what will happen? even though it is greater than or greater than equal to both comes over here, let's say I have greater than equal to also, then what will happen simply will be, it will be still called as strictly increasing in AB. Means in the open interval, if it is strictly increasing, then it will become strictly increasing. You don't have to worry about the boundaries. I'll reframe it. So even though, let's say, the continuity is given or the domain is given for AB closed, okay, but if at the point A and at the point B the function is not continuous, at the point A and point B the function is not continuous, then you will not bother about the boundaries. Basically check about the open interval of AB. If in the open interval, if you have the function always positive, then what will happen? It will be simply called as strictly increasing function. Do not worry, I have taken a question on this. I'll show you when I'm explaining that particular question once again. This whole process works. Let's move on. Sir. Okay. Now, if f is continuous in the closed interval of AB and differentiable in open interval of AB, then what happens is, if you have greater than or equal to 0 and equality holding at some points but not in any interval. Basically, understand this very clearly. If the equality, this equal to sign, check here, this equal to sign with the inequality, if the equality holds at points rather than in the interval, holds at point but not in the interval, then the function will become strictly increasing or decreasing, whatever it is. Okay, if it is less than equal to 0, greater than equal to 0, but that equal to is true only at certain point, not in the entire interval, then what will happen? It will become strictly increasing. But if equality is holding in the some interval, means there is an interval which is defined where the equality holds true, means you will get the flat line. See, whenever you have a flat line, means there will be a interval defined over there for the flat line. Then what happens is, it will not be strictly increasing, it will be simply increasing, also called as monotonically increasing in nature or non-decreasing in nature. Difference is very simple. If there is an interval involved, then we will have that as simply increasing or non-decreasing in nature. But you have, if the equality is involved in only some points at points, then what happens is the function becomes strictly increasing in the interval, closed interval of A and B. Clear? This is clear. Same goes with the case of decreasing as well. So function is continuous in the open interval of closed interval of AB. You have differentiable in the open interval of AB, and what happens? Derivative is less than equal to 0. Derivative is less than equal to 0, but this equality holds only at some points. Not an interval. Then the function will become strictly decreasing in nature. This is very important because questions like this can come in objective and you have to pick the right choice. Decreasing, strictly decreasing, increasing, or strictly increasing. You got to pick the right choice. Please give the attention on the screen right now. Very, very important. If you have equality hold in an interval, then you cannot have the case of strictly decreasing or strictly increasing, because you cannot have a flat line. You cannot have a flat line in the case of strictly decreasing or strictly increasing functions. Whereas if you have defined only at some points, you can call that to be strictly increasing function. Please check equality holding in some interval. Then what will happen? It will be simply decreasing function or monotonically decreasing function, non-increasing functions in the interval of AB. Very important. Monotonically decreasing, that is non-increasing in nature, not strictly monotonically decreasing in nature. Okay, this is clear. 2 points. It'll be very much helpful to you while solving the MCQs, whether it is for boards or for CET, because you'll not have much things given. The function will be given to you. You have to figure out the intervals. We'll learn that, don't worry, but you have to understand the concepts very much clearly. If you have a doubt, let me know. I'll again come back with a session where I'm going to explain you again with some more examples. But for now, let's get back to the questions. Okay, now sir, this big heading, working rule to find the interval in which function is increasing or decreasing. Let's skip it. Sir, why are you skipping this? Let's skip this also. Let's skip this also. I'm going to solve a question for you right now. I'm going to take a question. For that question, I'm going to solve for both increasing, decreasing, and from there we'll come back to the previous slides. Because if I ask you right now to read all of this, no, it'll become very much confusing, too many words, too many statements, and you will not like the concept itself. Then why not I give you the simplest trick, simplest way to solve the questions, and then you can go back and read this. You can download the class notes in the PDF format in the WhatsApp channel, and of course revise through it, right? But let me solve it for you. Let me show you. Actually, it is very simple than the words written on the screen. Starts like this. Find the intervals on which the function fx given like this, x upon 1 plus x square, is increasing and decreasing. Means for the given function this, you got to figure out where is it increasing and where is this decreasing. Figure out in what intervals it is decreasing and what intervals it is increasing for the given function fx. Step 1 is always the same. Step 1 is always the same. What is step 1? Step 1 will be finding, what is it? Finding derivative. So f dash of x you have to find out. You have to apply quotient rule over here. Differentiate x will become 1. Keep 1 plus x square as it is. Now put a minus sign, differentiate. So keep this x as it is and differentiate 1 plus x square. You're gonna get this as 2x divided by 1 plus x square the whole square. Right? Let's simplify this. I'm gonna get this as f dash of x equals to 1 plus x square in the numerator minus 2x square divided by 1 plus x square the whole square. This is my step 1 done. Step 1 is finding the derivative. This is cancelled, okay? You can find this as f dash of x is equals to 1 minus x square upon 1 plus x square the whole square. So derivative is clear now. Derivative is very much clear now. Now step number 2. Step number 2 will be again always same. Step 2 and step 1 is very similar. Okay, not similar means it will be always fixed. Step 2 is putting derivative equal to 0. To find what? To find the critical points. Okay, so let's do that. 1 minus x square upon 1 plus x square the whole square is equal to 0. This is a positive value. 1 plus x square the whole square is always positive. Please check. Okay, so you're gonna put this on this side. It's a non-zero value also. So when you do that, what I get 1 minus x square equals to 0. From here I can see I'm getting this as 1 minus x and 1 plus x. 1 minus x and 1 plus x. So you get two critical point as minus 1 and plus 1. Step 2 is done. Step 3 is basically, you can call this to be wavy curve method or the number line. Wavy curve method or simply the number line. Whatever you want to call, it's up to you. Draw the number line. What will come first? Of course minus 1 and plus 1. Minus 1 and plus 1. Check the coefficient of this factors. What the coefficient over here? There is plus, no problem. But here we have minus sign. We have minus x, right? So if the x coefficient is negative overall, okay, here this is plus. So this is plus and this is minus. Combination will become minus. Start with minus sign. I'll repeat myself. If the coefficient of the factors over here is negative overall, start with the minus sign. And then if, look for this, where is this factor coming from? 1 from here. Sorry, not from here. From here. 1 minus x, right? And how many times it's coming? Odd amount of time. If you have odd powers of that factor, if you have odd power of the factor, wavy curve method, odd power is there, change the sign, plus. Next one, minus 1, coming from this factor. Minus 1 and 1 are the critical points, okay, coming from the factors x plus 1 and 1 minus x, okay. Again, this is having also odd power. How come, sir? Because 1 plus x power 1 is there, right? Nothing means there the power is 1. So 1 plus x power 1 means again odd power, so sign will again change to minus. Minus plus minus we have now. What did we do? First step, found the derivative. Second step, put it equal to 0. Third step, drawing the number line and figuring out the intervals using the wavy curve method. Okay, simplifying the critical points, plot on the number line, check whether the coefficient of x is positive or negative for the factors all together. If negative means start with minus sign on the right side. Then keep changing the sign alternatively if the powers of the factor are odd. If even means, let's say if it was, it's coming as 1, right, from this part, 1 minus x. You get x equal to 1 from this factor only, right? And you had power as square over here. If you had power here as, let's say, 1 second, if this was, let's say, square, for some reason, if you factorize for some polynomials, you might get this as square. Then you will not be having sign change over here. This will simply become minus only. It will not change the sign. It will not change the sign in that case. If the power of the factor is even, the sign will remain same. But in this case, it's not true. All right. So we have now wherever it is, so what does this represents? It represents derivative is negative, positive, negative here. How can I say that, sir? Do one thing, put a value more than 1. Put a value more than 1. 2 you can put here 2. 1 minus 2 is how much? 1 minus 2 is minus 1, and put here 2 value again. 2 plus 1 is 3. 3 into minus 1 is how much? 3 into minus 1 is minus 3. It means for all value of x more than 1, the derivative over here becomes negative. Same if you put value between minus 1 and 1, put 0. 1 minus 0 is 1, 1 plus 0 is 0. Sorry, 1 plus 0 is 1. Multiply them, 1 into 1 is 1, again positive. So any value between minus 1 and 1 is giving the derivative as positive. Basically, I can simplify over here. So I'm on this area, I'm getting this f dash of x is negative, okay, and in this region I'm getting f dash of x is positive, okay, and over here I'm getting f dash of x is again, what is it, negative. Put the values, x as less than minus 1, I get minus 2. Put here, this will become 3, this will become minus 1, again minus 2 you're gonna get, which is a negative value. Okay, try from your side, put the values between minus 1 and 1, more than 1 and less than minus 1. You'll have this results that I've written over here justified. Okay, so now what are they asking? Decreasing and increasing. Look for first option. They're saying increasing. Increasing means derivative has to be positive. Increasing means derivative has to be positive. Where is it positive, sir? Only in this interval. So you're gonna start from here. X belongs to, what is it? Minus 1 to 1. Minus 1 to 1. In minus 1 to 1 we have, please check, we have this as positive. Okay, so answer for this one is minus 1 to 1. If they were written over here as strictly increasing in the question, if they would have given us strictly increasing, then we have to write here open brackets. We have to write here open brackets. There's a difference. Okay, we can't have the equality in that case. Okay, we must write open brackets on this side. Next one is decreasing in nature. Decreasing in nature. What are you going to do about this? Where it is negative, over here and over here. So right here x belongs to, the interval is negative of infinity to minus 1 union 1 to infinity. Please check. For the decreasing, where the f dash of x is negative, we have two intervals, right? From here to here, minus infinity to minus 1 and 1 to plus infinity. Okay, 1 to plus infinity and minus infinity to minus 1. That's my answer for part A and part B. I hope this is very much clear. Yes, I've taken some time to explain you this part, but I wanted to be very much sure that you all got this 3 steps. Step number 1, finding derivative. Step number 2, finding the critical point using derivative equal to 0. And the third one is drawing the number line, and fourth one will be, of course, figure out the intervals. This is step number 4 actually. Step 4 is finding the intervals. Okay, now if you go back to this, have a look. You can write step number 1 is finding derivative, finding f dash of x. Step number 2, find critical points. How do you do that? F dash of x equal to 0. Step number 3, number line. Okay, number line. What method do you use? Wavy curve method. Wavy curve method. 1 second. Okay, that's your method. Wavy curve method. Basically inequalities, right? Yeah. Step number 4, find intervals. Find intervals. What is it? Whether it is f dash of x positive or f dash of x is negative. And then write the answer. Write the correct choice if it is objective. Okay, and same is written over here also. Please read through this, all the steps. Please read through all the steps given to you over here, but I have also given you the simplest step possible, 4 simple steps to get cracking on all the questions of increasing decreasing function. Let's move on to question number 2 now. Okay, so that the function given by fx equals to sin x, strictly increasing over, okay, we have 3 sub questions in this. Strictly increasing strictly decreasing and neither increasing or not decreasing in 0 to pi. Okay, we'll see that. We'll see all the options. But right now we have to do what? Approach remains same. Finding the derivative is a must. Do one thing. Fx is given to you as sin x. First step is very simple, sir. F dash of x, do it. You're gonna get this as cos x. Derivative of sin is cos. Draw the graph. Now this whole problem comes with the help of the graph only. Which graph you gonna draw? This or this? Which one? For the second one, right? Because we want to know the trend with the help of derivative, right? So for cos x, the graph is like this. We want till pi only, so this is 0, pi by 2, and this is pi. Now understand this. So what I have so far, I have here 0 to pi by 2 positive, pi by 2 to pi negative. Okay, what is the meaning of this? This represents that cos of x is more than 0 over here, and this means what? Cos of x is less than 0 over here. I hope this is very much clear. In the first part it means cos of x is more than 0. In the next part it means cos of x is less than 0. Okay, clear. This much is okay. Now look at the first option. Strictly increasing in 0 to pi by 2. Yes, it is. Right, because cos of x is more than 0. Right, where in 0 to pi by 2, what it means is basically f dash of x is more than 0. What it means is basically f of x is strictly increasing in nature. Clear or not? Cos x is more than 0, basically what it means, derivative is more than 0. Hence, your given function is strictly increasing in nature. You might see, sir, this is decreasing in nature. This is not the function given to us. This is not the function given to us. What is given to us? They have given us sin x. Now you might be thinking, sir, then why don't we draw the graph of sin x and see from there only? You can do that. You can do that. You can of course draw the graph of f equals to sin x and understand the intervals and see whether it is increasing or decreasing. Of course, please check. Sin x, like this. Go here. Write like this, increasing, decreasing, you can do that, no problem. But in some question what will happen, the graph will not be that much clearer to understand with the help of fx only. Then learn to understand that, find the derivative, draw the graph of derivative, it will be clearer, right? It will be much helpful. Okay. So first point is clear, strictly increasing in nature. You can see from here also, this is pi by 2, right? In this case, what is there? Always increasing, right? This graph is always increasing in nature, no problem. So I've given you two methods. Draw the cos x graph, see the derivative sign and understand the nature, or draw the sin x graph and check the nature directly. Your choice. Okay, both methods I've given you. Draw the graph of derivative or draw the graph of function itself to check the nature of the function, increasing or decreasing. Clear or not? Right? Okay, second one is strictly decreasing in pi by 2 to pi. This is pi by 2, this is pi. What is happening to the graph? It's coming down. This is pi, right? What happens here? Coming down means decreasing. Check here. Pi by 2 to pi. What happens over here? In this case, you have over here as cos of x is less than 0. It means f dash of x is less than 0. It means fx is strictly decreasing in nature. Strictly decreasing in nature. It's coming down, okay? Strictly decreasing in nature. What about option number C? You see option C talks about the interval 0 to pi. Interval 0 to pi. If you check here 0 to pi from here to here, we have both nature, increasing and decreasing. That's why we can't take one case. That's why we're writing here neither increasing or decreasing in the interval 0 to pi. So I have already shown you all the three. I hope this is much clear. Okay, this is option number A. This is option number B. Option C you can see from here, right? This is plus and this is minus. Both cases are there. So it increases also and then comes back. Increases and comes back. That's why both of them are true actually. So both has to be the case, increasing and decreasing. This is my sin x graph. The graph of sin x. So you can draw the graph of sin x and understand the trend, or draw the graph of cos x, which is the derivative of sin x, and understand the nature of the derivative and check the trend from there. Clear? Very much clear. Question number 3, let's start. 3. Okay, this is the question that I've talked about, when we have on the boundaries, it's not continuous. We'll see. Please check. if you talk about this now on the boundary, what is the boundary here? Says 0, right? 0 to infinity, right? What is the boundary over here? 0 to infinity. So if of course you don't check this part, what about this part, sir? What about 0? You have to check that, right? If you check limit at 0, no? Limit fx at 0, you'll get the value to be -3 over here, right? But f of 0 is what? F of 0 is 0. F of 0 is 0, but limit value is -3. Are they equal? No. It means not continuous. Not continuous. Not continuous. Basically, so I'll not worry about the point 0 anymore. This was a concept, right? Whenever you have the boundaries, the two corners in the intervals, okay, where the given function is not continuous or discontinuous, then what happens? You only worry about the open interval of the function. So what is open interval? 0 to infinity. Now interval changes. Here at the point 0, this is the given interval for the given function over here. Please check 0 to infinity. Okay, but at 0 the given function is not continuous because limit is not equal to the given function's value at the point. Okay, then this will become open interval of 0 to infinity, and if you check the graph of this, you'll have to only worry about this part. Means you'll have open over here and the graph goes like this, x minus 3. And in this case, what is the graph nature? Always positive. This is always increasing in nature, right? So f dash of x, if you check, it'll come out as 1, which is always positive. It means f dash of x is more than 0, therefore f of x is strictly increasing in nature. Strictly increasing in nature for option number B. Please check. It's not increasing, it is strictly increasing because of the nature of the graph over here, not continuous at the point x equals to 0. I hope this is clear. Okay, can we continue question number 4 now? Question number 4. All right, so let me know everyone that question number 3 is understood, sir. In the comment section you have to reply right now. Question number 3 understood, sir. Please let me know, because I want to be very confident that you understood this concept. Very important, very important. I'm telling you, repeating more and more times is very important, sir. Okay, question number 4 now. A function fx equals to this is a polynomial function is what? This is a simple question. I'll show you. Step number 1 remains always same. Derivative you have to find. You get 3x square for this part. For this you're going to get minus 6x. You'll have plus 3 over here. We can take 3 common. You get x square minus 2x plus 1. Right? Right? This is a formula, right? Identity x minus 1 the whole square. F dash of x. Think about it. Can this be ever negative? 3 is a positive number. 3 is a positive number. X minus 1 the whole square. Again, either positive or 0. So basically, my f dash of x is either more than 0 or equal to 0. It can never go to negative side. So a derivative of fx is what? More than or equal to 0. Okay, for any value of x you take, what happens is, given function going to be increasing in nature. Of course, not strictly increasing, we are not saying that, but it's going to be always increasing in nature. I hope this is very much clear. This is very much clear. Your given function fx is increasing in nature. Done. Clear. Question number 4 understood? Question number 4 understood. Okay. Question number 5 now. Find the values of x for which the function basically given to you as again a polynomial function. You have to find what? The interval where it is decreasing in nature. Now please pay attention to this question right now. I can give you this as homework also, but I want to explain one question properly to you where I find the interval, because like this question will be asked. I'm very much serious, whether it is KCET or your Comet K or your boards, this question can be asked. Very important. Figuring out the interval, extremely important question. Let's have a look. Step 1 remains same, finding f dash of x. 3x square plus 24x plus 36. I can take 3 common, right? Yeah, I get x square plus 8x plus 12, right? 12, oh, okay. Factorize this, you'll have 3 times of x plus 6 and x plus 2. How can I say that? Have a look. 6 into 2 is 12. 6x and 2x becomes 8x, and x into x is x square. That's my f dash of x. 3 times of x plus 6 times of x plus 2. What is the next step? Put this equal to 0 to find the critical points. If you check here from the first bracket, you're going to get x equals to minus 6. Second bracket, what are you going to get? X equals to minus 2. So you have now two critical points. You have now two critical points, minus 6 and minus 2. Okay. What is the next step? So right now we have done step number 1 and step number 2. Step number 1 was finding derivative. Step number 2 is finding the critical point. Step number 3, the wavy curve approach. Draw it. Step number 3 is drawing the number line. This is negative infinity. Minus 6 will come over here. Minus 2 will come over here. This is plus infinity. That's my number line. Okay. Look at the coefficient of the function, the derivative function. Positive over here for x, positive over here for x. You have to look for the overall, okay? Positive means it's positive, right? The coefficient is positive over here. You got to start from the plus sign. Yeah, we have to start from here, plus sign. Okay? That's my first one. On the right side of minus 2, it's plus. Now look for the minus 2. Where is coming from? X plus 2. What's the power of x plus 2 factor? 1 means odd. Sign change. Minus. Now look at minus 6. Minus 6 is coming from this factor x plus 6. Power of x plus 6 is again 1. Odd. Sign change. Plus. Okay? Sign change is plus. Got it? So we have plus minus plus. So basically have a look. In this reason, we get f dash of x as positive. In this reason, I get f dash of x as less than 0, and again in the last reason we get f dash of x is more than 0. We have 3 reasons now. What we're looking for? We're looking for decreasing. We're looking for decreasing means we're looking for f dash of x is less than 0. Which one is correct in this reason? Okay, it means f dash of x is less than 0 in which interval? When x belongs to minus 6 to minus 2 open. They've given only open intervals, right? So answer will be x between minus 2 and minus 6. Option is B. Option is B. Have a look. Option is B. A very simple question. Now if they ask you what is the interval where the given x is increasing in nature, you got to say negative infinity to negative 6 and minus 2 to plus infinity. Okay, clear? Simple enough. Very simple. Fifth one is done. Let's move on to question number 6 now. Question number 6. The function given to you where x is not equal to 0, of course, the domain is defined as all real minus 0. Please check. If you put it here as 0, no, it will become undefined, right? So you got to take domain as except for all real, except for 0, all real numbers are the domain. We're looking for what is the nature, decreasing, increasing, or whatever it is. Let's check. So first step is to find derivative. You'll have 3, you'll have minus 1, you'll have x power minus 2, will be again 0. We get what here? Minus 3 upon x square. I've done the step so that all of you understand how you find derivative of 1 upon x, right? Minus 1 upon x square is the derivative. We get the answer as minus 3 upon x square. Clear? Okay. X square is a positive number. X square is a positive number. 3 is a positive number, right? Square of any number is positive. 3 is a positive number. It means we have this as minus sign of 3 upon x square. What it means is minus sign of a positive number, right? This is a positive number. This whole thing becomes what? This whole thing becomes less than 0. This whole thing becomes less than 0. Because minus of 3 by x square. Minus of 3 by x square. 3 is positive, x square is positive, hence whole thing will be negative. I get the answer as decreasing for all r minus 0. Why like this, sir? Because your domain is saying that x is not equal to 0, right? You got to say what? All real number except for 0. Don't get tricked by this, what is written over here. That's the domain actually. That's the domain part. Question number 6 is one step question. Your answer is here. Option A is correct. Decreasing in all real. Because derivative is less than 0. Derivative is less than 0. Okay. If you had option given here as decreasing or strictly decreasing. If you had option given here as decreasing or strictly decreasing, which you going to choose? you have to choose what? You have to choose strictly decreasing, because this can never be 0. This can never be 0 actually. Any value of x, this will never be 0. So of course, if you had two options saying that decreasing or strictly decreasing, you have to choose what? Strictly decreasing. Okay, 6 is done. Question number 7 now. Function fx equals to x times of e power 1 minus x. Same thing. We are looking for decreasing, increasing in nature. First step remains same again. F dash of x. Differentiate this. You have to use what? Product rule. Product rule. Yes. Differentiate x. You're gonna get this as 1 e power 1 minus x. Keep x as it is. Differentiate e power 1 minus x. You're gonna get this as e power 1 minus x. Is it over? No. Apply the chain rule. You're gonna get over here as minus 1. Okay. So now you take this e power 1 minus x common, you have 1 minus x left. Okay, put this equal to 0, put this equal to 0. Okay, and alright, we don't need that, we're looking for increasing or decreasing. Understand this, this is always increasing in nature, right? This part is always increasing in nature. It's an exponential function, it's a exponential function, always going to be increasing in nature, always positive. It can never be 0 also. So you have no values over here. You have only one value x as equal to 1. But check the coefficient. Coefficient is minus 1. I told you. Very important. Please check. You have only one critical point over here, which is x equals to 1. But this will be negative and this will be positive. How come, sir? Because coefficient of x is minus 1. What about this? This you don't worry about, because this is going to be a non-zero value. So don't worry about this part, only this part you check. It'll become what? It'll become 1 minus x, right? So x coefficient is what? X coefficient is negative in nature. So that's why you start from the minus sign on the right hand side and then you go to the plus sign. Alright. So please check intervals. Strictly increasing in the interval 1 by 2 to 2. No. There's no interval like this. 0 to infinity, no interval like this. 0 to 2, no. This is correct, right? Option D is correct. Please check. Strictly decreases in the interval 1 to infinity. The interval 1 to infinity, from 1 to infinity is negatives, right? In the interval x belongs to, what is it? 1 to infinity. Okay, I'll keep it open. What happens over here? This whole thing becomes f dash of x is actually less than 0. Therefore, option will be what? Fx is decreasing in nature. Fx is decreasing in nature. Option D is correct. Option D is correct. So very much clear to understand why we are using the number line with a minus sign on the right hand side, because the x coefficient is minus. Because of the x coefficient being minus, we have to start from minus sign over here. Question number 8 now. Problem number 8 now. The function fx equals to e power ax, e power minus ax, where a is a positive value, a greater than 0 means a is a positive value, is monotonically increasing in nature. A, which is the given function, is monotonically increasing in nature. Okay, we have to look for the interval of x. Let's find it. Let us solve this now. Steps remain same. Question changes, our approach remains same. Step number 1, find derivative. Step number 2, find critical points using derivative equal to 0. Step 3, number line using wavy curve. Step 4, figure out the interval. Okay, f dash of x, 0, put it over here, you get e power ax. Derivative of ax will become what? A. Move on from here, plus e power minus ax. Derivative of this is e power minus ax. Derivative of minus ax will become what? Minus a. Alright, take a common, and what are you gonna get? You'll get over here e power ax minus e power minus ax. That's my derivative if you take a common. Okay, now they're saying that it's given as increasing, means this has to be more than 0. This has to be more than 0. Correct, na? It's given as increasing means it has to be more than, of course, 0. Please check. We don't have any equality over here. That's why I can just ignore this. I can ignore the inequality as greater than equal to 0. Alright. This is a positive value. This is a positive value. Correct? A is given as positive. Means this will have no effect on the inequality. This particular value will have no effect on the inequality. Alright. So if I go ahead with this, I can get e power ax minus e power minus ax more than 0. What I get from here? Please check. From here I'm getting e power ax is greater than e power minus ax. What it means? you get e power ax, and greater than 1 upon e power ax, cross multiply, you're gonna get e power 2ax is more than 1. So I hope this part is clear, right? I've taken this over here. If you want, you can take e power ax common over here, e power 2x also, it becomes the same thing, okay? I'm getting e power 2ax more than 1. More than 1. All right. Then what? Apply log on both sides. You get 2ax left over here. You get 2ax left over here. And this will become what? This will become more than 0. More than 0. All right. Then if you check a is a positive value, a is a positive value, then of course x has to be a positive value. Because if x becomes less than 0, we're looking for increasing function, right? We want this whole thing to be increasing in nature. A is positive value, 2 is also a positive value, then x also has to be positive in nature, right? Then of course I'm going to get what? X as positive. How are we getting from here to here? Applying log on both sides. Applying log on both sides. Okay, I get log of e power 2x as simply 2ax, and log of 1 is 0. Log of 1 is 0. Equality remains same. Equality remains same. I hope this is clear. Clear, right? Okay, got it. That's it, I think. That is it. Please check answer is x more than 0. Option D is correct. Now you can have a different approach to solve this question. You can have a different approach to solve this question, but answers would come as option D only. Because to solve the exponential functions, we can have more than one approach. We can use different formulas of exponent to get the same result. But answer should be x more than 0. If you are getting a different approach, let's say you can use over here as taking e power minus. Basically, I can take this on this side also as e power minus 2ax, right? I can take this as common. All right. We'll have e power minus 2ax less than 1. We can go like this also. So you can have more than one approach to solve this question, but answer should come as x greater than 0, which is option number D. This is a constant. This has to be always true. Whatever method you take, option D has to be the right answer. Please check question number 8 is done. Question number 9, let's start now. The function fx equals to x plus cos x is what? Same approach, sir. Find f dash of x. X becomes 1 and this becomes minus sin x. 1 minus sin x. 1 minus sin x. Okay. Think about a sin x function. It can either go to minimum of minus 1 or maximum of plus 1. A sin x function can either go to minimum of minus 1 or maximum of plus 1. If you take, let's say, extreme 1 minus of minus 1. If I take two extremes, 1 of minus 1, I get the answer as 2. If I take other extreme, which is 1 minus of plus 1, answer will be 0. Basically, f dash of x, which is given equal to 1 minus sin x, can either be greater than 0 or equal to 0. Think about it. If you put minus 1, you get the answer as 2. If you put the extreme value, which is 1, you get the answer as 0. So given function can either be minus 1 or positive or 0. It can be positive or 0. Okay, it means increasing in nature. So you're basically what you're getting, f dash of x will be more than 0. So the fx will be what? Increasing in nature. Option A is correct. Not certain A range. For every value of x, the f of x is going to be increasing in nature. Not for certain value, every value of x. Okay. If you want to do the derivative approach, you can do this. Otherwise, from the graph also you can see cos x has a limitation of minus 1 to 1, but not x. Okay. This is clear. Question number 9 is clear. Question number 10 now. Beautiful question. Question number 9. Know the range of the sin x, and that is enough. Okay. Find the interval in which the function is decreasing in nature. Okay. Same thing repeats. Derivative. Differentiate x minus 1. You're going to get this as simply 1 only. You'll have x minus 2 the whole square left over here. I'm using the product rule. Right? We'll have a plus sign. This time we're going to keep x minus 1 as it is and differentiate this part. You'll have twice of x minus 2. Okay. Sir, what about the chain rule, sir? It'll come out as 1 only, no? If you differentiate x minus 1, you get the answer as 1. That's why I did not write over here. If you differentiate x minus 2, answer will again be 1. Okay. So what is common over here? I have x minus 2 common. I get x minus 2 left on this side, and we have plus twice of x minus 2. I'm multiplying this 2 with this bracket, 2x minus 2. Okay. So what I have so far, x minus 2 I have, and I get this as 3x minus 4, right? 2x plus x is 3x minus 4. Put it equal to 0, I get two values, x value as 2, and from here I get x value as 4 by 3. So we have two values of x as critical points, 2 and 4 by 3. Next step is to do what? Draw on the number line. 4 by 3 will come in front, right? Yeah. 2 is over here because 4 by 3 is something 1 point something, 1.333. Yeah. Okay. This is negative infinity, this is of course plus infinity. Great. We are looking for what? We are looking for decreasing in nature, right? Start from here. Both sides x coefficient is positive only, right? 3x and x. So plus, minus and plus. We are looking for decreasing means negative. We are looking for decreasing means negative. So in this case we have f dash of x as less than 0 only when x belongs to 4 by 3 to 2. Over here. Option D is correct. Beautiful question. Very simple. Done. Please check. They're not simple because I've taken this as simple because this is as the question comes in your examinations, whether it is boards or a KCET or Comet K. The question is like of this trend only. That's why the questions are like this. Okay. So I have not made the questions easier from my side. They are relevant question for your examinations. Question number 11 now, the last question of the day. Let's complete this and complete our session. Okay. If the function fx equals to a sin x plus 2 cos x upon sin x plus cos x is increasing for all the values of x, then which of the condition for a is true? Which of the condition of a is true? A step remains same, finding f dash of x. Okay. I'll need some space over here. Alright. Let me start. Because I have to apply what? I have to apply quotient rule. And there are too many terms, so we have to be careful over here. A plus sin x, we have to differentiate the numerator first. So we get here a cos x minus 2 sin x. That's the derivative of your numerator first. A cos x and minus 2 sin x, derivative of numerator. Continue, keep this as it is. Sin x plus cos x is kept as it is, right? Denominator will be kept as it is. Denominator will be kept as it is. Next is, there's a minus sign of course. This time you're gonna keep the numerator as it is. So right here, a sin x plus 2 cos x. Now this time you have to differentiate the, this is the product sign, okay? This is the product sign over here. Differentiate the denominator. Sin x will come as cos x. Sin cos will become minus sin x. Done. What about denominator? Square of sin x plus cos x. Sin x plus cos x the whole square. Whole square means all is positive. I don't have to worry about this part, okay? I'm looking for an increasing function. So you don't have to worry about this part because it's going to be always positive in nature. It's a whole square. Always positive in nature. So we'll not worry about that part, okay? Great. This is step number 1. Let's move on to step number 2. Expansion. Multiply this, I get a sin x cos x. I get a sin x cos x. For this I get what? Minus 2 sin square x. Minus 2 sin square x. Sin x is done. Let's move on to cos x. We get a cos square x plus a cos square x. And this we get minus 2 sin x cos x. Minus 2 sin x cos x. This is clear. Expansion of the first two brackets, okay? There's a minus sign of course over here. And cross check. A sin x with this I get again same thing. A sin x cos x, these two, and we get here 2 cos square x plus 2 cos square x. Okay, cos square x. Move on with this, I get minus a sin square x, these two, and we get here minus 2 sin cos x sin x, cos x sin x. Close bracket. Okay, and divide whole thing by a positive value. This thing. I want to write that, right? It's the same thing. Sin x plus cos x the whole square. Now check carefully. Over here, I have to continue f dash of x. F dash of x. For this, what I have? A sin x cos x. Cancels this a sin x cos x because we have a minus sign over here. This and this will cancel each other. Anything else? No. Have a look. So I'm getting this as minus 2 sin square x and minus 2 cos square x, because there's a minus sign outside, right? This will become minus. I'm taking this minus 2 common. I'm getting here minus 2 common. It becomes sin square x plus cos square x. Clear? Okay. Clear, right? I'm taking this minus 2 and minus 2 from here common, because there's a minus sign outside. I'm taking this minus 2 common. It becomes sin square plus cos square. These two terms are gone. What about this? We are getting here a cos square plus cos square. Please check this too. A cos square plus cos square. All right. So I can take a common. I can take a common. It will become sin square x plus cos square x. Okay. Correct, no? These two terms. This and this. There's a minus sign over here. It makes this as positive. It becomes a is common. I get cos square plus sin square. Cos square plus sin square. This is clear. Let's check this term out here. I have minus 2 sin x cos x. Minus 2 sin x cos x. And this minus will become plus over here. It becomes plus 2 sin x cos x. So these two are cancelled. These two are cancelled. So my answer is simply divided by this. Have a look. So f dash of x will become what? This will become simply a minus 2 by a positive number. By a whole square over here. By a whole square over here. Please check. I'm looking for increasing means more than 0. Derivative is more than 0. From here what I get? A minus 2 by the whole square will be more than 0. It means a minus 2 will be more than 0. It means a is more than 2. Option is D. Option is D. Not a difficult question. It is calculative. I understand that, but not a difficult question at all. Okay? Yeah. But if it comes, it will be time taking. You can save time using high speed only. Means if you are good in the calculations, if you know the formulas properly, and then you can save time. Otherwise, it will be time taking. There's no short trick for this. Question number 11 is done. Okay. I'll cross check. If there's a trick for this question, I'll give it to you in one of the trick video. I'm making a trick videos for all of you, right? So when I find a trick for this question, I'll give it to you. Right now, you have to spend time in this. Very easy question, but you have to spend some time in this particular type of problems. 11th one is also done. I hope there's no doubt in the 11th one. Okay. So first step was to find a derivative. I have ignored denominator because it's always a square. Okay. And rest is cancellation. So this is the major step over here. And from there you can figure out that it is coming as a minus 2. Answer is a greater than 2. It's not a difficult question at all. Question number 11, answer option D is correct. This completes our session today. I hope you had fun. I hope you learned something. So with this, I can conclude something. If you have any feedback, if you want to let me know something, if you have a requirement from me, you have to let me know in the comment section only. With this, of course, I can end the session today, and the PDF of the class notes will be uploaded in the WhatsApp channel. So please join the WhatsApp channel if you have not joined yet. If you're new to the channel, subscribe our channel. You are here to make sure that get your preparation right, and we are here to make sure the same thing by giving you always required content that you need to prepare in the best way to get your results in across the top rankers in next year's CET examination. You can see your toppers are over here. We had a meet, we all talked, we had fun time. You can also be part of our team once you score a very good marks. Okay, our goal is very simple. We have to score top 1000 rank. This is very much possible. It's very much possible. I saw some comments in one of my videos. Sir, is it possible to score 1000 rank from here? If you start right now, can we score this? Answer is yes. Sir, I am an average student. Can I score this top 1000 rank? Answer is yes. Why this answer is yes, sir? Because the thing is, no, we want to do something, but we don't take the action on that, right? If you take the action on what you want to do for your goal, of course you can change the way your life is right now in the studies. Very much possible. If you want to get top 1000 rank, let me know. You are here for top 1000 rank in the comment section, and we'll make sure that you are among the toppers next year, being consistent in the process, asking your concerns, asking your doubts, attending all the sessions that is scheduled on platform, attending the live sessions, ask your concerns and doubts over there also, and other requirements that you have, you're going to ask us in the comment section right now. Okay, so please let me know if you want to score a top 1000 rank. It's possible. It's possible. Just believe in me. It's possible. You have to score. You have to be very good in your boards also, because you know that your KCET examination is based upon both PU2 and your result from KCET examination. So of course you have to be very good in boards. So you have to score 295 plus or 290 plus in boards. Is it possible, sir? Yes, it is possible. It's totally possible to score 295 plus. You don't have to be very genius to get this marks. You don't have to be genius to get this marks or 295 plus. The thing that matters is going to be what? Is going to be you being consistent, getting your small doubts cleared, taking one topic at a time, one chapter at a time, and sticking to the schedule. If you do that, you'll be for sure getting that marks in boards and the CET examination. Boards 295 plus, CET 150 plus. Believe me, you'll be the topper next year. Your seniors also doubted themselves. Your seniors, when I told them this, they doubted themselves. Like, okay, sir, can we do it actually? But they did that. They got this outstanding result. That can happen if you are consistent, if you are very much, believing in yourself and changing the process. Every time if something is not working out for you, take that out and bring a more efficient way. Ask us, will help you in that. Okay, so with this I can end the session today. I had fun teaching you all. I hope you had fun learning from me. I'll see you again very soon till the next session. Take care. Bye bye.